welcome back to our channel. So in the previous session we have seen the graph terminologies and the introduction to graphs. So now in this session we'll go with another concept in graph, that is graph traversals. So our topic is graph traversals. So what is meant by this traversals? So traversal means visiting all the nodes. That means traveling around all the nodes in the graph. So here we will not have any root node, so we can assume any node as a starting node. Any node as a starting node. And from that starting node we have to visit all the nodes without any repetition. That means every node of a graph should be visited only once. Right? Now we are having two types of techniques in this traversal, graph traversals. So the first one is depth first search traversal. It is called as DFS. And the second one is breadth first search. Which is called a BFS. Right? So based upon the depth we will travel all the nodes of a graph, that is called a DFS. Based upon the breadth, that means level. So we have to visit all the nodes of a same level, then only we will shift to the next level. So that in such a way we will go with the BFS. We will implement this BFS. So in order to implement this DFS and BFS, we will use the stack data structure. For implementing the DFS, we will use queue data structure for implementing the BFS. Right? So now let us take an example and we will see the procedure, how the DFS will work and how the BFS will work. It's a very simple topic. Right? Now, coming to this DFS. See, let us take an example here. A, B, C, yes, so you can go with this one. Okay, so you can go with this one. This is a graph. So graph is also similar to a tree, but a graph can contain cycles, that means loops. So this is a graph, of course. Alright. So now first let us assume this one is a start. So we can assume anything, any node can be a start. Okay, I will assume that a start for simple understanding. Right. So I will visit one by one. Okay. So after visiting this one, so I will place a weight as 1. I have visited A, I have placed it as 1. Now I am coming to C. Right. So you can go with the B or C, anything else. Okay, both are same. You can visit either B or C. So we can get a different outputs. Okay. So I will visit C. So the C weight is 1. Now from the C again there are two adjacent nodes. So we can visit any one node. Okay. So I will go with the G. And the weight of G is 1. Now it is a leaf node. There are no nodes. Okay. There are no adjacent nodes. We should not say it is a leaf node. We are not having any adjacent nodes. So backtrack C and go with another adjacent node. Right? And mark it as 1. So here also there is no adjacent nodes. Again backtrack. So again the node is visited. So go with the adjacent node. So B will be 1. Now again B is having two adjacent nodes. We can go with the D or E. Anything. Okay. So I will go with the D. Mark as D1. Again there are no adjacent nodes. Backtrack. Right. Again go with the E and go with the 1. So there are no nodes. Okay, there are no adjacent nodes. Backtrack and again backtrack. Again we came to the start node and there are no adjacent nodes. There are no adjacent nodes. So this is how we can use this DFS. So first we have visited A, then C, then G, again backtrack C. So already C is visited, so we should not write C. Next F, right? Next no adjacent nodes, again C is visited, again A is visited, B, and then we have visited D, no adjacent nodes, backtrack B, already there. Now E. So E, there are no adjacent nodes, again backtrack to B is there, backtrack to A is there. So there are no adjacent nodes, any other adjacent nodes. So this is the DFS of a given tree. So right here. Okay. So this is the DFS for the given graph. Right? Now we'll go with the implementation part. So for implementing this one, we will use the stack. So for the step 1, consider a stack and consider the DFS expression. Right? So starting node, push the starting node into a stack. So A will be presented here. So A is pushed here. Now pop the A and place it in the DFS expression. Right? So this is the DFS expression. So step 2. In the step 2, so popping the A and placing A here. Now place the adjacent nodes. Place the adjacent nodes here. So we'll go with adjacent nodes B, C. Push the adjacent nodes of A. Push the adjacent nodes of A. So what are the adjacent nodes of A? B and C. So we can write B, first we can push the B and then C, or we can push C and B. So if you push C and B, the output will be different. So both are same. So here both are the adjacent nodes, we can visit any node. Right. So next step, we have to pop the, so already C is visited, so we have to pop the C and push the adjacent nodes of C onto the stack. So step 3, B, A and C. A and C. Now what are the adjacents of C? F and G. So F and G. Right? B, F and G. So we can write first, we can push first F and then G, or we can push first G and then F. Anything is correct. Okay. So I am pushing the F first and G in the next. Now remove the element and push the adjacent nodes of that node. So here G is a leaf node, right? So it doesn't have any adjacent nodes. So just pop that node and place in the DFS. So step 4, A, C, G, so B and F are there. B and F are there. A, C, G. Okay. Then step 5. Same. So here G is not having any adjacent nodes. Leave it. Now F. Remove the F and push all the adjacent nodes of F. So already the DFS expression is having A, C, G, and now we are placing F here. So F is also having no adjacent nodes. Leave it. Now B. Step 6. Stack is empty. A, C, G, F and B. So just pop the element and push the adjacent nodes of that element. So what are the adjacent nodes of B? That are D and E. So first I will push E and then D. So anything we can do. First D and then E, or first E and D, because both are the adjacent nodes. Right. So after that step 6. Now step 7. What we have to do? Again, pop the element and push the adjacent nodes into the stack. So here D is having no adjacent nodes, just pop the element. So step 7, E, and in the DFS A, C, G, F, B and D. Right? Now only one element in the stack. The same thing, apply the same thing, pop the element from the stack and place the adjacent nodes of that node into the stack. Here E is also having no adjacent nodes. So just after step 8, the stack is empty and the DFS traversal is B, D and E. Right? So stack is empty. Stack is empty. Right? So don't get confused. Just I have written empty. Okay. Okay. This is empty stack. Empty. Right? So if you observe this one, we got the same thing. A, C, G, F, B, D, E. So by using the stack, we can implement this DFS approach. Right? So this is one way we can implement this one. So one more thing I just want to say here, both are the adjacent nodes. Need not worry to push the order of, pushing the order of nodes into the stack. So we can follow any order. So you can push B first and then C next. We can push first C and then B, so that we'll get a multiple number of outputs. So if you push first C, so here we have applied, push operation first on B, then C. So we got this one. If you apply first C, then B, we'll get the next one, another one, another output. So don't get confused, right? So hope you understood this session, a simple DFS approach, depth first search. For implementing this depth first search, we'll go with the stack. So which is called a BFS. So in order to implement this BFS, we'll use the queue data structure, which is a first in, first out queue. So let us take the same example and then the same procedure is followed. So here also we have to visit all the nodes only once. So we can assume the start from any node and then we have to start traveling and we have to visit all the nodes only once. The same thing, we'll take that A, B, so the same example I am taking, D, E, F, G. Right. So first travel from A, so mark it as 1. So then visit the adjacent nodes, all the adjacent nodes. So first 1, and there is one more adjacent node, 1, right? Then coming to the next level, visit the adjacent node of B and then visit the adjacent node of E, backtrack, right, because there are no adjacent nodes here. So backtrack to A, again backtrack, come to C, so visit F and backtrack to C, visit G, backtrack to C, backtrack to A, so that all the adjacent nodes have been visited. So here we have to visit the nodes in level wise. So first complete the level top level, level 0, and then level 1, level 2, level 3. So top level we have to complete all the visiting all the nodes, then go with the second level, go with the third level. Now we'll go with the implementation. So here after visiting all these things we'll get the same order A, B, C. So A level 0, level 1, level 2. So level 0 visit the node, level 1 visit all the nodes, B, C, level 2 visit all the nodes, D, E, F and G. So we have to visit all the nodes level by level. So that's why we call it as a breadth first search. Okay, so in the previous session we have seen a depth first search. We have to go in a depth. Right. Now we will see how we will get this one with the implementation of queue. So step 1. So this is a queue and this is a BFS. Q and BFS. So first, so let us assume this one is a start node. Okay, the same thing, start node is A. So A, right, insert A into the queue. So this is a queue. Okay, step 2, remove the element from the queue and place in BFS. So as it is a queue where we have to remove the element, so both the insertion and deletion will be applied on same end. Okay, so sorry, so deletion will be from front end, insertion will be from back end, rear end. Okay, so A is removed and placed in BFS. Now insert all the adjacent nodes of A in Q. What are the adjacent nodes in A? B, C. B and C. So this is a BFS and this is a Q. So in the step 3, and remove the element from the queue. So here we have to remove the element from the front end. We have to insert the element at the rear end. Okay, so we have to remove the element. So the C will be in the top and place here A, B. Now what we have to do? We have to insert all the adjacent nodes of B into the queue. What are the adjacent nodes of B? D and E. So D, E. So the insertion will take place at the rear end. So this is a front. At the rear I have inserted D, and next at the rear I have inserted the E. So at the rear end I am inserting the nodes, adjacent nodes of B, because we are removing B here. Next, in the step 4, remove the element from the queue. Remove the element from the queue. So C is removed because the element is deleted from the front end. So D, E, A, B, C. Now what is the element we have removed? C. Now place the adjacent nodes of C into the queue. Place or insert the adjacent nodes of C into the queue, because we are removing C from the queue. So what are the adjacent nodes of C? F and G. So insert them into the queue, F and G. So apply the same procedure. Step 5. Right. So already A, B, C are there. Now remove the element. So deletion will be done from the front end. So D is deleted and placed here. Now there are only 3 elements, E, F and G. And we have removed D. So we have to add the adjacent nodes of D into the queue. So here D is a leaf node. So here D doesn't have any adjacent nodes. So just ignore. Next, follow the same procedure. Step 6. So A, B, C, D, and remove the element. So element is removed from the front end. So E will be removed, and we have to insert all the adjacent nodes of E into the Q. So what are the adjacent nodes of E? There are no adjacent nodes. Ignore. So there are only 2 elements in the Q. Step 7. Remove the element from the Q and place it in the BFS. So what is the element? F is removed here and placed in BFS. And we have to insert all the adjacent nodes of F into the Q. So there are no adjacent nodes for F. So remove, just remove. Next, step 8. Step 8. So A, B, C, D, E, F. So G is removed. So G is placed here, and we have to insert all the adjacent nodes of G into the Q. So there are no adjacent nodes for G. So here Q is empty. So this is the Q and this is the BFS. So the same thing we got here, A, B, C, D, E, F, G, A, B, C, D, E, F, G. So this is how we can implement the BFS, breadth first search, using Q. So hope you understood. So here we are visiting all the nodes level by level. So we have to visit all the nodes in level 0, then only we have to go with the level 1, then only we have to go to the level 2, right? So here A is in level 0, so we have visited A in level 0. In the level level 1, there are 2 nodes which are adjacent to A. So A, B, C. So we have visited B and C. And then we will go with the level 2 because only 2 nodes are there in level 1. In the level 2 there are 4 nodes and we have to visit all these 4 nodes before entering into the next level. So visit all these nodes because all these nodes are adjacent to B and C, all the nodes of level 1. So D, E, F, G. So we are visiting D, E, F, G and go with the next level. So there are no other levels, right? Because level 2 is the last level. So this will be the answer. And this will be implemented by using the Q. Just insert the node into the Q and then first insert the node into the Q if the Q is empty. If not, remove the element or remove the node from the Q and enter into the BFS. Place it in the BFS and insert all the adjacent nodes of that particular node into the Q and follow the same procedure. So first we have inserted A and we have removed the A and placed it in the BFS, and we have to insert the elements of adjacent nodes of A into the Q. There are 2 adjacent nodes B and C, so B and C, right? In the next step we have to remove the element from the Q. So where we have to remove the first element from the front end. So from the front end we will remove the node from the Q and we will insert all the adjacent nodes of that particular node into at the rear end, right? Because here we are using the Q, all the insertions will be done on front end, all the deletions will be done from the rear end, right? So we have to delete the element and we have to place it in the BFS. So this is a very simple traversal technique, BFS, breadth first search, right? Hope you understood this simple technique. So if you are having any doubts regarding this BFS, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. So thanks for watching, keep following, thank you very much.